You're building retrieval augmented generation, and you need a place to store embeddings and run similarity search. The default reflex is to reach for a dedicated vector database or Azure AI Search. But if your operational data already lives in Azure Cosmos DB for NoSQL, you can add vector search right next to it. In this video, I'll walk through how native vector search in Cosmos DB works with Azure OpenAI embeddings, the index trade-offs that actually matter, and a clear framework for when to choose it over a dedicated store. Before comparing products, pin down what you're actually optimizing for. 5 criteria drive this decision. First, data gravity. Do your documents already live in Cosmos DB? Second, scale. Thousands of vectors or hundreds of millions. Third, query pattern. Pure similarity or filtered hybrid queries mixing metadata and vectors. Fourth, recall and latency targets. And fifth, operational cost measured in request units and storage. Colocation wins when your vectors and operational records are the same documents, because you avoid a second system, dual writes, and sync lag. The flow is straightforward. Your application sends text to Azure OpenAI, calling an embeddings model like text embedding 3 small, which returns a vector. You store that vector as an array property inside the same Cosmos DB document that holds your content and metadata. At query time, you embed the user's question the same way, then run a query using the VectorDistance function, optionally filtered by partition key or metadata. Cosmos returns the nearest documents, and you feed them as context to your chat completion model. One system holds both the source data and the index. Here's what the search actually looks like. You declare a vector embedding policy and a vector index on the container when you create it. Then you query with VectorDistance, passing the stored property and your query embedding, and order by that score. Because it's just the NoSQL query language, you can add a where clause on any metadata in the same statement, which is how you get hybrid filtering without a separate engine. Match your distance metric, cosine here, to how your embedding model was trained. Cosmos DB offers 3 vector index types, and this choice drives both cost and recall. Flat does an exact, brute force scan, perfect recall, but it scans every vector, so it only suits small collections. QuantizedFlat compresses vectors to cut storage and request units while staying fast at moderate scale. DiskANN is the approximate nearest neighbor index built for large datasets, giving low latency and high recall at millions of vectors, with a small recall trade-off you can tune. Rule of thumb: start with DiskANN for anything production-sized. So when does a dedicated store win? Azure AI Search brings richer retrieval features, built-in hybrid scoring with BM25, semantic ranking, integrated data ingestion and skill-based chunking, and fine-grained relevance tuning. Cosmos DB for NoSQL wins on colocation, transactional consistency with your operational data, global distribution, and one billing and security model. If retrieval quality and search features are the product, lean AI Search. If vectors are an attribute of records you already store and operate in Cosmos, keep them together. A few practical cautions. Vector dimensions are fixed by your embedding model, so 1536 for text embedding 3 small or 3072 for the large model, and changing models means re-embedding everything. Large vectors inflate document size and request unit cost, so consider whether you need full or reduced dimensions. The vector indexing feature has had preview stages and capacity limits, so confirm region availability, maximum dimensions, and index limits in the current Azure documentation before you commit a design. To recap, Cosmos DB for NoSQL lets you store Azure OpenAI embeddings beside your operational data and query them with VectorDistance, with flat, quantizedFlat, or DiskANN indexes. Choose it when data gravity and a single system matter. Choose Azure AI Search when retrieval quality and search features are the core of the experience. Your concrete next step: Take one existing container, add a DiskANN vector index on a small sample, and benchmark recall, latency, and request unit cost against your real queries before scaling out. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.